Okay, this is 8G8, 8th grade geometry, standard 8, video 1, the Pythagorean theorem and the distance formula. Here are a few terms to know. Please copy these down in your journals and define them. Today we are going to use the Pythagorean theorem and the distance formula to find the distance between two given points. These are two different ways of solving the same type of problem. You are very familiar by now with the Pythagorean theorem, so we're going to start with that. And then the distance formula is actually, it looks more scary than it is, and I'm going to try to describe how the distance formula is derived out of the thoughts of the Pythagorean theorem. So let's just start here with these points M and N. After we run it through the theorem, it also says here that we're going to have to round our answer to the nearest hundredth. So be very careful in the directions as to what they want you to round to. All right, if we're using the Pythagorean theorem, the first thing we do is take these 2 points and plot them on a grid. So you'll be given some graph paper, you have your own graph paper, and we're going to plot these points here. So point M is at 6, 3. Let's see how that is. All right, so start at the origin, we go 1, 2, 3, 4, 5, 6. That's the distance on the x-axis, and then we go 1, 2, 3 on the y-axis, and we will label that as point M. And then we do the same thing with point N. So we need to go to 5, 7. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and we make our second point and label it point N. And we are trying to find the distance in units from M to N. So let's grab a line out of here and connect those 2 points. All right, if the line were completely horizontal or vertical, running on the axes, parallel to the axes, we would be able to count the units to find the length. But since this is on a diagonal, it's on a slant, we are able to create a right triangle out of these 2 points. And you might be able to see them right now. I'm going to draw them in. So I have another point right here, and you can't really see it, but as the lines, I only have one pen at a time, but as the lines come to the left and then go upwards or downwards, these 2 purple dots will intersect. At this point, we'll call it point L, and hopefully you are seeing the right triangle that we can create out of this. So we'll bring down this leg, and then we'll bring this leg across. And there you have a 90-degree right triangle, and we can use Pythagorean's theorem because we can count the units for your A and your B, and then you'll be able to figure out what point C, or I'm sorry, leg C is. All right, so A and B are interchangeable. We'll call this A, and we'll call this one B. Well, what is A equal to? Counting from the N going to the L, we have 1 unit, 2, 3, 4. So if A is equal to 4, we have B being equal to, we have 1 unit box from L to M. So we'll call that 1. All right, let's go over to the left and use the Pythagorean theorem to decide what the distance is between that MN. All right, so it's A squared and B squared. We have A as being 4 squared, B is 1 squared, 16 and 1, and 17 is equal to C squared, And we can't stop there. We want to find the square root of 17. So if c squared is 17, then c must be equal to the root of 17, and that is not on the perfect square chart. So we need to do an approximation. So take out your calculator at this point and type in the square root of 17. And then we need to round to the nearest hundredth position. So there's the 10th, and so 2 is in the hundredth. We look to the right of the 2. The 3 tells me to keep it the same. So C is not equal to 4.12. It is not equal to 4 and 12 hundredths. C is approximately. Let's get into the habit of using the correct symbol when we do rounding or estimating here. Okay, final answer. That was using the Pythagorean theorem. Now, I'm going to introduce this distance formula to you. I told you it was a little scary looking. And basically what we're going to be doing is taking our points and plugging them into this formula, and it's apparently going to spit out the same answer as what was on the last page. So let's do that. Let's just plug in the numbers where they belong. It says x subscript 2 minus x subscript 1. That quantity is going to be raised to the second power. And there's all the square root, and let's just plug in the numbers of our x's. Well, before we do that, we have to label the x's. So you can label this x sub 1, and then in the other ordered pair, that would be x sub 2. That's why they name them 1 and 2, because they're both x's, so they have to be called something different. And then this would be x sub 1, I'm sorry, y sub 1, and then we have y sub 2. So we have the first ordered pair number 1 and the second ordered pair number 2. And plug in our numbers underneath here. So we have the quantity, we take our 5, and we subtract the x sub 1, which is 6, and to that we're supposed to square it. Well, in essence, what that's saying is that we are taking this 5 minus 6 on the x-axis. These are your x's that we're talking about here. And we are finding the difference between them. Well, what is 5 minus 6? That is negative 1. And if we were to square it, negative 1 times negative 1 is 1. All right, well, let's go back to our picture and see what that relates to. Where did this distance formula come from? Well, the distance between 5, if we look over here, 5 and 6, if these are my x's, I'm running along the x-axis, that was the distance between L and M, and we knew that that was 1 unit long. All right, so what happened there, when we square it, that's what we did in the first line after the Pythagorean theorem. So we took our 1 unit from L to M and we squared it in the Pythagorean theorem, and that was the distance between these two x values. Okay, then to that we are going to add the distance between the two y values. All right, so who is the y sub 2? That would be my 7. And then in y sub 1 we have a 3, and we're going to square that. All right, 7 subtracted by 3 is 4. Squared would get us our 16. Well, how does that relate to the Pythagorean theorem? If we were on our y-axis, which is your vertical line, that is the distance between L and N, and hey, lo and behold, there's that 4 unit box that we were talking about, and we squared it and we got our 16. So it's like running the Pythagorean theorem using the distance formula, because we ended up with our 1 unit box squared and our 4 unit box squared to get 16. And then we get the total of being 17. And if you see in the formula up top, we have this square root. After everything that we've done, we take the square root of that answer, and we said that that is going to equal, I'm sorry, it's not going to equal, it's going to be approximately 4 12/100ths. Okay. We're going to try a new example. The pages look the same. I apologize for that. But we're going to use two different ordered pairs and try to go through this one more time. So let's plot -1, 3, -1, 1, 2, 3, and we'll call that M. And then we have 5, -2, 1, 2, 3, 4, 5, 1, -2, and we'll call that N. Take out a straight edge, and we'll connect those 2 points. And we need to find the distance in units between those 2 points. Well, we notice that it is a slanted line. It is also known as a diagonal. And we're assuming right now that this is the hypotenuse also. And why can I assume that? Well, I can assume that because we can create a right triangle out of any diagonal. And let's see where those 2 points are going to kind of collide as we run our pen. It looks like they're going to collide right down here vertically and horizontally. And we found it. And we'll label it L. All right, so take your straight edge and create your 90-degree right triangle. If you want, you can even draw on the little box here. All right, so C has been located. That's the hypotenuse. We need to find that distance. We are going to use the Pythagorean theorem. So we have our theorem. And we need to figure out what numbers to plug in. And we are going to count the unit boxes. So we have 1, 2, 3, 4, 5 units for one of the values. Square it. And then we run horizontally 1, 2, 3, 4, 5, 6 units squared. And let's just calculate here. So C is equal to the square root of 61, which is not perfect, so it's calculator time. The square root of 61 rounded to the nearest hundredth is 7 81/100ths. The 0 makes the 1 stay the same. So C is approximately 7 81/100ths. Final answer. All right, now if we don't have access to graph paper, which you're not always going to have the graph paper, here is where the distance formula comes in handy. Whoa. Okay, let's label our coordinates. We can call this x sub 1, and this one is x sub 2, y sub 2. All right, so it's just plugging in and solving. I'm just going to give you a heads up here. Stay away from the calculators when you're using this particular equation and most other equations. If the numbers are pretty small, there really isn't any reason to use it. If you don't type the negatives in correctly, you're going to end up with an incorrect answer. So my thought is always use the paper and pencil, and you won't come up with those calculator errors. All right, so x sub 2, we're going to take 5 subtracted by x sub 1, and this is what I was talking about. So we have back-to-back negatives, and if you don't use the parentheses correctly, it's going to be messy for you. All right, we're going to square it. So that is going to be either your a squared or your b squared. Those are interchangeable. So the distance between your x's on the grid plus, here's your Pythagorean theorem, plus the distance of your y values on the grid. Even though we don't have a grid, we're thinking in terms of that. So y sub 2 is negative 2 minus 3. There's your b squared. Okay. Now it's calculation time. 5 minus negative 1 is 6 squared plus negative 2 minus another 3 is negative 5. Negative 5 times negative 5 is positive 25. So we have negative 5 squared gets us 25 plus 36. I think that looks familiar. That is going to give us 61. Following the formula, the last step, we have this square root of the whole part, the whole quantity. So we take the square root, and that is going to be approximately, because we're rounding, it's not perfect, and we came up, I think it was 7.81, and it was. And let's label it. You know, we haven't done any labeling. Since we don't have centimeters or inches, we're going to call these units. So 7 and 81, approximately 7 and 81/100 units. I'll go back and label the rest of them because that's what I do. I'm a math teacher. I like to label. So we'll put in units. We'll go back another one. We'll call it units and units. Sorry about that. I should have done that from the get-go. In your journals, I'd like you to define the given terms on page 2 of the flip chart. Write a few sentences on what you've learned from this video. We are going to do these in class together. We'll get the whiteboards out and work the distance formula. We'll talk maybe a little bit more. I'll explain a little bit more about how the distance formula is kind of related to the Pythagorean theorem. You've gotten really good at the Pythagorean theorem, so I'm excited to get going on this formula too. I'll see you in class.